we're going to be working on factoring special cases. We're going to be talking about what a difference of square is. We've been doing factoring, just our binomials. Thumbs up if you know what a binomial is. We've been factoring trinomials. And I know Caleb hasn't been here, so we're going to have to help Caleb. Trinomial. Factor. Maybe you might not be able to give me a definition. Can you tell me what a factor is if I give you an example? Perfect square. We started talking a little bit of perfect squares yesterday. Difference in mathematics, what would that look like? Looking subtraction. And then area models. We were using area models to multiply our polynomials. So today, it's a little bit different because if I give you a trinomial, if I ask you to find my GCF, and you cannot find the GCF, what will you tell me about that polynomial? You had some of the homework yesterday. Camila? It's a prime binomial. Or trinomial, whatever it is, right? But today, I'm going to give you some of them. And if I ask you to look at those ones, and I ask you, what's my GCF? What does GCF stand for, Leila?
Greatest common factor.
Greatest common factor. So if I ask you, what's my GCF of that first one? Do we have any? 1. What happens if my only GCF is 1? Can I do anything with it?
No.
Stay the same. But what I tell you that you can actually factor it out. So today, that's your goal. You're trying to figure out what are these polynomials or binomials have in common that I can actually look at a pattern and figure out how to factor it out. Because right now, what you know so far, you will tell me that is a prime binomial, but it's not actually a prime binomial. So we're gonna have some time to think. Everybody has their notes already? Okay, so I'm gonna give you some time to think. No writing, no talking. I want you to think what happens when we have two perfect squares. You know what a perfect square is, right? And it eliminates each other out. So I gave you some of them, and I want you to look at them and see if you can see something they have in common. There's something they have in common. We're not writing yet. What do you notice about each term? Remember, we have binomials, so there's 2 terms. And what do you wonder about how they could be factored? Because at this point, you're telling me it's a prime binomial. So I'm going to give you a minute. No talking, no writing, just thinking about it. What do you see that they have the same, or what do they have different, or what do they have in common? Or what could you do to factor those binomials? Just think about it. Okay, so that's your thinking time. Now that you thought about it, maybe you figure out what they have in common, what do they have the same, what do they have different. I want you to actually write about it. Tell me what is it that you notice? Remember, I prefer a complete sentence, but if this time you cannot give me complete sentence, I need some bullets. Give me something in there. What is it that you notice about those polynomials? What do they have in common? What do they have different? What do you think you could do to factor them out? Or you still think they're prime binomials? It's okay to tell me that too. Let me see. Give you a minute. We're not judging, just write what you think. Thumbs up if you need a little bit more time. Are we good with the time? Okay. Now that you thought about it and you wrote about it, you're going to share it with your partner. And let's see, since I moved some of you a little bit off. Vale, talk with Zoe, and then you can talk with them. Partner A, this one's, raise your hand, partner A. Partner A on this side. And partner A, do we know who we are? So partner A, your job right now is to listen. This time partner B is gonna talk. So you're gonna share it with them. So partner A, what's your job?
Listen.
Listen without
Talking.
without talking and You don't judge. Remember, you're just listening. You're not giving them feedback yet. So you're gonna, partner A, what's your job?
Listen.
No judging. Partner B, you're gonna be sharing your ideas. So go ahead, turn to your partner and share what you wrote.
Alright, so I wrote that all of them have a exponent that's either 1 or greater. And then I also wrote that each factor also has a number that's also greater than 1. That's all like positive. There's none of them are negatives.
That's good.
Are you ready to share, Mila? Who was sharing here? What did she tell you?
She told me that each term has a common factor of 1, and that
The variable?
each variable has a
Square. They're quadratic, right? Okay. So say thank you to your partner. Now we're gonna switch roles. Now we're gonna switch her. The ones that listen, you're gonna be speaking, and then the other ones are gonna be listening without judging. Go ahead. And this time I'm only gonna give you 30 seconds since you already shared once. So go ahead.
Okay, so what I wrote is that each one at least has one that is squared, and each equation is being subtracted. But that was a good one where they're greater than 1.
I actually didn't notice that they are being subtracted. That was good.
Thank you.
Okay, let's see. Who's gonna pick? Who's gonna share now with the class? Remember, you're together. So if you cannot share, your partner should be able to help you. Let me pick someone. Who's gonna be the first victim? Let's see. Oh, Isabel went home, right? Let's see. Diego. Can you mind sharing with the class what you and your partner discuss?
Sure.
Tell us.
We said that they are all squared,
What do you mean they're all square? What does that mean?
that they have an exponent too,
What is they? What's they?
and all the ones that have variables.
But what is that? What do we call those things?
An exponent.
What has the exponent? So just the variables have exponents? Is that what we're saying? This one has an exponent? So we can say, do we agree, kids? Other variables have exponents of 2? Okay, so we can put that. What do we notice? We can say here, all the variables have exponents. If you want to add to your thinking, you can go ahead and add right now. Do not erase what you wrote. Just add to it. All variables have exponents of 2, which makes them what?
Squared.
Linear or quadratic. Makes them quadratic, right? So we have quadratics in here. What else, Diego or Gia? Anything else you'd like to share with the class? All of them are being subtracted. Let's see. I'm subtracting. Do we agree? Yes, so let's add that in case you didn't have it. So all the binomials are being subtracted or have subtraction, right? What word did we say today that will mean the same as subtraction in math?
Different.
Difference. So that's what we're looking at for the difference. Gia and Diego, since you went first, volunteer another partners. Cato's group, Cato and Adrian. Anything that you would like to add to that discussion that we had? You or Adrian. It doesn't have to be Cato. Remember, you're working together. No? You got the same? Anyone else that would like to add, Athena? The greatest common factor is 1, right? And that's what we said, that if I was to factor, a lot of you would say that those are prime binomials because the only GCF we see it's a 1. So we couldn't do much at that point. Anything else that you think we should write? Confirm with your partner if you're not sure what you have. Or is this too easy? You know what to do, Kiara? You know what to do?
Yeah. And I noticed the pattern.
You notice the pattern?
Yeah, but I'm not sure how to do the last two.
You're not sure how to do those ones? Did you rewrite it like I asked you? Sorry. Did you rewrite it like I did? Because I wanted it in this format, right? So maybe if you rewrite them in that format that I asked you, see if you know what to do with the last one. Because yes, it gives you the same answer, but you're not writing in the same pattern that I'm asking you. Yes. Did you notice? Okay, let me have you for a second, please. Pay attention to the board. Make sure we're writing this as that pattern that I asked you to rewrite it. Yes, at the end, you're going to have a product, but I need you to be able to rewrite it as a product of those two binomials. Because if you just give me the numerical value of it, you might not see what I'm asking for that pattern that you're looking. So if you're not rewriting it as this, you might not see the pattern that we're trying to see. So if you did not, go ahead and fix it, please. Did you do it, Annie? The pattern? Yes.
X squared minus 16.
What would it be?
Would it be like 16x squared?
I don't know. Are you following this pattern? See some of you a little bit at the end. Maybe we're not sure what to do with that X. Is that X throwing you off? Thumbs up if you're done. One. Need more time?
Yeah.
A minute? Try it. I'm gonna give you a minute and I'll bring you back. If you're struggling with the last one, it's okay. We'll put it together. So I'm gonna stop right here. I know you have some that's still to do. So I'm gonna give you that as a homework, but I'm gonna give you an exit ticket. Now go back to your places. Thank your partner, please. Thank you. So I'm gonna give you a sticky note, and I need you to write your name and answer those questions that I have right there. You do not have to rewrite the question, but if you need it, you can rewrite it. Do I want complete sentence? Yes, complete sentence, please. Do your best to do the complete sentence for me, please. So grab one, make sure you write your name. And we get us not a psychic. So make sure we have names. Cowboys. Okay. So write your name. First question. Is 8x squared minus 2 a difference of squares? Why or why not? Number 2, factor 36a squared minus 25. In your own words, explain the pattern and steps for factoring a difference of squares. And then number 4, an example of a difference of square is because and tell me what. Remember your goal today was to figure out the pattern to be able to factor a difference of square. Difference of square is not a prime binomial. There's a way to factor out, but you have to understand the pattern. So go ahead and answer those 4 questions for me. As you're answering those questions, I'll come back to it. Let's kind of put the steps. In order to know if we have a difference of squares, first you gotta look always for what? We gotta look for our GCF. If you don't look for that, it might not look like a difference of square like the one that we had with the factor GCF of 3. It didn't look like a difference of square until you factor out the 3. So make sure you do that. I'll come back to the questions. Or you have I think the questions are in your notes. They're in your notes. Check the signs. Make sure we have a what in between the 2 perfect squares. Subtraction or a difference, a minus. Make sure both of them are perfect squares. And you're gonna follow that pattern. So you can look at the questions that you have in your notes. And then I'm gonna project this to help you a little bit. Follow the steps. Make sure you write your name on the top, please. See a few without names. Anyone needs any clarification on the questions? On that one, you just have to factor out for me. Number 2. When you finish your exit ticket, I want you to go back to the last slide and summarize today's lesson and submit your notes. So we're gonna do our exit ticket. Let's see. We're gonna do exit ticket. And I'll pick them up and then go back to the notes and summarize today's lesson. What was our goal? And submit your notes. Remember, your goal was to be able to factor a difference of squares. See that pattern of having a perfect square and being subtracted from another perfect square. Number 3. Okay, so what needs to happen in order to be a difference of squares? Tell me what needs to happen to your terms. What operation should you see in order to determine that it's a difference of squares? Again, once you're done, make sure that you go back, type your summary. Now your summary is your notes. You can do sentence, you can do bullets on the notes. I expect sentence on the exit ticket, but your notes at the end, you can do bullets or you can do sentences. Those are for your view. Once you have it or you think you have it, you raise your hand and I'll pick it up. Thank you. Thank you. Thank you. Make sure you go to your notes, either write sentence or bullets to summarize today's lesson. What is the difference of squares? That's what I'm looking. If you need the vocabulary, you know where it is to help you answer that. Got it? Yes. Can you what? Can you help? Okay, what do we say was the first step you gotta do? And I know you haven't been here, but what was it like on this one? What was the first step we had to do? What do we do here? What do we do with that 3? So that we're looking for so if we look at this one, it does look like we have a difference in square, right? But what did Matthew forget to do? If we look at 4 and 36, do we have any common factors? So he forgot to what? To factor out a 4. So factor out a 4, kind of like the way you did here, and see what you end up with. And I know you haven't been here, so just come next week for tutoring so I can help you. So if I wanted to summarize today's lesson, what would you say? Genesis, you got it. What would be my summary for today? Let's say who's absent? Isabel's absent. If she comes back on Monday and she wants to know what she missed, what would we tell her? Good luck? What are we going to tell her? How are we going to help Isabel that she's absent? I know some of you are still working, the ones that are done. If I give this to Isabel, let's say I have a 9x squared minus 25. What would you say to her? Julie? I have to simplify. How do I simplify that? Okay, first thing we gotta do is what? Look to see if we have what? GCF. Second thing, do we have a GCF on that one? Julie? 9 and 25? 1. So can I do anything with it? No. Once I know I don't have a GCF, I know it's a binomial. Have we? What else could I do? What would I tell her? Check for GCF, and then in order to follow the pattern, what must happen? What needs to happen? Does this follow the pattern?
Yes. Yes.
Does it follow the pattern? Why? What's the pattern?
Subtraction.
We have a subtraction, which we also call a
Difference.
difference. What else is happening?
They're perfect squares.
They're both perfect squares. So we can tell Isabel, first look for GCF and then look for what? That we have what? Two perfect squares. And we have a what? Subtraction. Once we know that we have taken care of these three things, what will we do? 9x squared can break apart into what?
3.
3x and 3x. 25 can break apart into
5.
5 and 5. So we say, Isabel, it's so easy. We can do what?
Factor them out.
3x, Julie, plus 5, and 3x minus 5. This is what I'm looking for you to verbalize to me. In order to see a difference of square, first we gotta look to see if we have a GCF. Second, we gotta see that both of the terms are perfect squares. And what operation do we have between them?
Subtraction.
Subtraction or difference. And then we can follow the pattern. This is a shortcut, but if you don't recognize that it's a difference of square, you're gonna miss that and say, if you don't know there's a difference of square, what will you tell me? There's no GCF. You would have tell me what? If we can't see a GCF, what would you say? If you did not know that this is difference of square, what would you have told me yesterday? Prime binomial, right? But now we know that you can actually factor it out. It's just a special pattern. Any questions before I dismiss you to the next period? No? Who's still writing? Make sure we submit our notes. Hold on to the paper. We're gonna go over some of them on Monday. Make sure we follow the last one. Not the last one. Number 7. I need to make sure we got number 7 in there. It's a little bit tricky. Questions? Anybody else with the exit ticket? Okay, let's start getting ready and we'll wait for the bell. If you borrow a charger, put them back, please.